Hi everyone. In this video, I want to talk for just a few minutes about using proportions to solve distance, rate, and time problems. Okay, so just a quick refresher, we've seen this before, but we have the formula d is equal to r times t, where d is equal to distance, r is equal to rate, and t is equal to time. Okay, so as long as your units are all good here, you should be able to find the distance traveled, the rate, or the which is the speed, or the time it takes to accomplish this, right? So let's look at a couple of examples here. Here we have the first one says a plane has a cruising speed of 300 miles per hour when there is no wind. At this speed, the plane flew 600 miles with the wind in the same amount of time as it flew 400 miles against the wind. So we want to find the speed of the wind. Okay, this is, I will admit, these are moderately complicated problems, but they're not so bad once we break them down a little bit. Okay, so to start with, we're going to make a table. Okay, so we start by finding all the information we know. So we know the speed of the plane. We know how far it traveled with the wind. Okay, and we know information about against the wind. Okay, so we need to know the distance the plane traveled. We need to know the rate. Okay, and we need to know the time. Okay, so let's start by seeing what we can do here. Okay, so if we know that the distance that the plane traveled, we're given this already, all right? So with the wind, the plane flew 600 miles. Okay, so it flew 600. Okay, and against the wind, the plane flew 400 miles. Okay, and then for our rate, we know that we can probably assume that if the cruising speed is 300 and we're flying with the wind, we can add the speed of the wind to it. So we could say 300 plus x. Okay. All right, 300 plus x. Okay, admittedly, this is probably simplifying the physics a little more than it should, but we'll go with it, right? So 300 plus x. And then against the wind, we're fighting it. So the wind will be taking away from the speed. So we'll say 300 minus x. Okay. Okay, and so if we go back up to our formula here, d equals rt, we need to solve for time. So we have d equals rt. If we want to solve for time, we can divide both sides by r, and we get that t is equal to d over r. And we're given the distance, and we're given the we're given the distance and the rate, so we can actually use both the distance and the rate to find what t is. Okay, so we know that the time is going to be the distance, which is 600, over the rate, which is 300 plus x. Okay, and then similarly for against the wind, we know it's going to be 400 over 300 minus x. Okay, so now what else do we know from this? And this is probably another piece we have to put together here. We have that the time is the same. Okay, so it said at this speed the plane flew 600 miles with the wind in the same amount of time. So what we know is that the time for with the wind, okay, is equal to the time against the wind. So therefore we can set each of these times equal to each other. So we can set 600 over 300 plus x equal to 400 over 300 minus x. Okay, so not too bad here. Now all we have to do is solve for x. Okay, so to do that, I want to go ahead and multiply. We're gonna cross multiply here. We're gonna multiply this side here by 300 minus x. Okay. Well, actually, no. Let's go back a little bit. Let's yeah. Let's go ahead and start by multiplying both sides by 300 minus x. Okay. This will cancel, and then we're going to have 300 minus x times 600 over 300 plus x is equal to 400. And now we can multiply both sides by 300 plus x. Okay, so therefore, these are going to cancel. And then now we're given 300 minus x times 600 is equal to 400 times 300 plus x. And now we can go ahead and try and simplify and solve for x. Okay, so we're going to distribute the 600 here to the x and to the 300. Okay, so we're going to get 180,000 minus 600x is equal to, if we do 400 times 300, should be 120,000 plus 400x. Okay, and so now what we need to do is let's move the 600x over here. Okay, and let's move the 120,000 over here. Okay, so what we're going to end up with is we have 180,000 minus 120,000 is going to give us 60,000 is equal to 1,000x, because 400x plus 600x is 1,000x. Okay, and that's going to give us that x is equal to 60,000 divided by 1,000, which is going to give us 60. So the speed of the wind is 60 miles per hour. Okay, 60 miles an hour. Now, when you're doing these problems, it's probably a good idea at the end, once you've solved one, to do, as I always describe it, as a sanity check, okay? So, for example, if you were to end up with a negative number here, that wouldn't make sense for the speed of the wind. I've never checked the weather forecast and seen that we have a negative wind speed, all right? And also, you probably wouldn't expect to see, the wind speed going 10,000 miles an hour either, right? So just this is a really good time to just say, does this answer make sense with the nature of this question? I would say a 60 mile an hour wind at the cruising speed of a jet doesn't seem completely unreasonable. So I think that's a fair assumption that you've probably done something right. Okay, let's look at another one. Here we have a passenger train traveled 110 miles in the same amount of time. Here, that's a key phrase again, same amount of time. It took the freight train to travel 90 miles. The rate of the freight train was 10 miles per hour slower than the rate of the passenger train. Okay, I want to find the rate of the passenger train. So let's make a table again. So we have the freight train, and we have the passenger train. Okay, move these down. Okay, and we have the distance, we have the rate, and we have time. Okay, so we know that to start with, we know that the freight train traveled 90 miles. So we can go 90 for the freight train, and a passenger train traveled 110. Okay, So let's just go ahead and say that just for simplicity's sake here, let's say x is equal to x is going to be equal to the rate of the passenger train. Okay, so here what we're going to do is we're going to say, well, this is x. Okay, we know the passenger train is x. That's the rate of the passenger train. Okay, and we know that the rate of the freight train was 10 miles per hour slower than the rate of the passenger train. So let's go ahead and do x minus 10 for our rate here. Okay, and remember, if we solve for time again, just like we did last time, we had t was equal to d over r. So we can say that the time for the freight train is equal to the distance divided by the rate. So we can say that this is 90 over x minus 10. And then here we have 110 over x. Okay, but the last thing we have here is that, like we said at the very beginning, we have the same amount of time. So our times are equal here. So if the times weren't equal, there's not a whole lot you could do with this, or there are things we could do, but not with the tools we have here. But we know since the times are equal that we can set these equal to each other. So we have 90 over x minus 10 is equal to 110 over x. Okay, so now we're going to cross multiply. So let's multiply this side by, let's multiply both sides by x. Okay, and then we'll multiply both sides by x minus 10. Okay, so the x's here will cancel, and the x minus 10's here will cancel, and we get 90x is equal to 100 times x minus 10. Okay, so if we simplify this, we get 90x is equal to 100x minus 1,000. I'm sorry, this is 110. I keep running 100. It's 110. Sorry, so we're going to have minus 1,100. Okay. So now we can take minus 110x away from both sides, and we get negative 20x is equal to negative 1,100. Okay. And if we divide both sides by negative 20, these will cancel, and we get x is equal to negative 1,100 divided by negative 20. And we're going to get that x is equal to 55. Okay, so the speed of the passenger train is equal to 55 miles per hour. Okay, and again, it's really good to ask the question: does it make sense that the rate of the passenger train is 55 miles an hour? Does that seem like a reasonable number? Again, yeah, I think it does. But this is a good time for a sanity check. Like I said earlier, you know, you're not going to have a passenger train going 1,000 miles an hour. I know there are some pretty crazy trains out there, but this sound like this is one of them, right? And you're not going to have a negative rate either, right? So this would be a really good time to do a sanity check to make sure that your answers make sense.